Ladies and gentlemen, let us have a look at differentiation, and basically on differentiation, the second concept that we are going to look at in differentiation is the derivative of a polynomial, because previously we looked at the derivative of that is the derivative of y that is y equals to that is ax raised to n. That is, in our previous lesson, we look at that is the derivative of y equals to ax raised to n. Now, this is the second concept that is in differentiation that we are going to look at. This is the second concept that we are going to look at. Now, a polynomial in x is an expression of the form that is a polynomial in x. I want us to briefly look at a polynomial, what a polynomial is. I want to say that a polynomial in x is an expression of this form, that is a, we have 0 here, we have x raised to n, then we have plus a, this is 1, x raised to n minus 1, then plus, we have this is 2, this is 2, that is 2, x raised to n minus 2, then plus that is a n. We have plus here. Now, this is a polynomial in x. A polynomial in x is an expression of this form. A polynomial in x is an expression of this form up to here. That is up to here. That is a polynomial in x. If you can just have a look at this expression. That is a0 is the subscript, a1, a2, up to an. These are constants. These are constants. That is, we have a 0 as the subscript. We have 0 at the subscript. We also have 1 at the subscript. Then we have 2, 3, and maybe going up to n. Those are constants. But n is an integer. N is an integer. Now, let us have a look at the first example. Now, this is a polynomial. Now, how can we differentiate this polynomial? How can we differentiate this polynomial? Now, for us to differentiate this polynomial, we have to differentiate, that is, each term in turn. We want to we have to differentiate this term individually, then we differentiate this, then we differentiate this. That is, we differentiate each term in turn. Now, we have y equals to x squared plus x plus 1. Now, if we differentiate this, that is, we are differentiating y with respect to x. In this case, we differentiate each of the term in turn. Now, this one is x squared. How do we differentiate x squared? We shall bring this to here. Then, x raised to 2 minus 1. Then, plus, we have x, let's say this is raised to 1, because x raised to 1 is just x. Now, you bring this one here. Then, we have x. That is, we bring this one here, and then we have x raised to 1 minus 1. Then, plus. This is 1. That is x here. The x that is here is x raised to 0. Now, x raised to 0 is 1. 1 times 1 is just 1. That is why there is no need of writing x raised to 0. That is here. We just write x squared plus x plus 1. Now, the power of x here is 0. So we shall bring it here. That is 0. Then, we have 0 times 1 times, this is 1, x raised to 0. Then we less the power by 1. Then we less the power by 1. Then we close the bracket that way. Now, in this case, let us proceed to simplify. Now, we have 2x raised to 2 minus 1 is just 1. Therefore, there is no need of writing that one. Then we have 1 times x raised to 1 minus 1. 1 minus 1 is 0. X raised to 0 is 1. Because any number or any unknown raised to 0 is 1. 1 times 1 is just 1. Plus 0 times the whole of this. 0 times any number is just 0. Therefore, there is no need of writing that. We'll leave it at that point. Now, this is the derivative of, that is this polynomial that we have here. This is the derivative of this polynomial that we have here. Now, let us have a look at this example again. That is y equals to, open the bracket, x plus 2, close the bracket, open the bracket, x minus 1. Now, in this case, the first thing that we shall do is that we shall expand this. Therefore, we have y equals to, that is x times the whole of this, that is x times x minus 1. Then we have plus 2 into, we have x minus 1. Now let us open the bracket. We shall have y equals to x times x, it will be x squared. Then x times negative 1 will be negative x. Then we have plus here. 2 times x will be 2x. 2 times negative 1 will be negative 2. Therefore, if we collect the like terms, we have our y equals to x squared. Then minus x plus 2x is just plus x. Then minus 2. Now, reaching at this point, we can now differentiate. Now, dy over dx, that is, we differentiate y with respect to x. Dy over dx is just, if we differentiate this, we shall have 2x. That is, we bring this power here, which is 2. Then we write this x raised to 2 minus 1. Then plus, the power of x here is 1. Therefore, it will be 1 times x raised to this 1 minus 1. Then we close the bracket. Then minus, that is 2. This is 2. We have an x raised to 0 here. That is not written. X raised to 0 is just 1. Therefore, there is no need of writing it. That is why it was not there. But in this case, it is imperative to know that there is x raised to 0. It is good to know that there is x raised to 0. Now, if you bring this 0 here, it will disqualify the whole of this in differentiation, and it will be 0. Now, this will be 2x raised to 2 minus 1 is just 1. Therefore, it will be 2x. Then plus, this is 1 into x raised to 1 minus 1. 1 minus 1 is 0. X raised to 0 is 1. 1 times 1 is still 1. Now, that is, this is the derived function that we obtain from differentiating that polynomial. Now, let us have a look at this example again. That is y equals to x raised to 3 plus x squared plus x over x. Now, in this case, we shall have y equals to, we shall simplify first by having x cubed divided by x. That is x cubed divided by this x. plus x cubed, not x cubed but x squared divided by this x, then plus this x divided by this x. So in this case, if we simplify, x by x1 by x will be x squared. Then by this one, 1, by this one will be x, then this one and this one simplifies. Therefore, we have our y as this x squared, then plus this x, then plus 1. That is what we have. Now, we can easily differentiate this. Now, let us differentiate this. That is dy of dx will be, we shall bring this 2 here, therefore it will be 2x raised to 2, then we less the power by 1. If we say 2 minus 1 is 1, therefore there is no need of writing that. Then plus, if we differentiate this, it will be 1. Now, if you differentiate 1, it will be 0, because if you differentiate a constant, it is always 0. If you differentiate a constant, it is always 0. But if you differentiate, maybe this one is x raised to 1. If it doesn't have a coefficient at this point, it will be that power, and its power is just 1. So, because if you bring this one here, and you less the power by 1, it will be 1x raised to 1 minus 1. 1 minus 1 is 0. X raised to 0 is 1. Therefore, 1 times 1 is still 1. Therefore, this is what we obtain in differentiating this function. Let us have a look at this fourth example. Now, that is s equals to 2t cubed minus 3t squared plus 4t. Now, this is a function of displacement. This is a function of displacement. Now, we shall differentiate this with respect to time. We shall differentiate this with respect to t, and t denotes time, but s denotes displacement. Now, ds over dt will be, we differentiate this, that is, we bring this power here, that is 3 into this 2t raised to 3 minus 1 is 2. Therefore, I will have it like this. Because if we less the power by 1, it will be 2. Because here is 3. If we less by 1, it will be 2. Now, we have minus, this is, the power is 2. We shall bring it here. Into, this is 3t raised to 2 minus 1 is just 1. Therefore, there is no need of writing that. Then we have 4t. If we differentiate 4t, it will just be 4. Because the power of this is 1. And if we bring it here, 4 times, that is 1 times this 4t raised to 1 minus 1, t raised to 1 minus 1. 1 minus 1 is 0. T raised to 0 is 1. 1 times 4 is 4. Therefore, it is just this 4 that we have written here. Now, in this case, we shall obtain, that is, if we open the bracket, it will be 6t raised to 2 minus 6t, then plus 4. That is what we obtain. That is what we obtain. Now, generally, the derivative of a polynomial is obtained by differentiating each term in turn. That is what we can conclude from the examples that we have done. That for you to obtain the derivative of a polynomial, you need to differentiate each term in turn. Each term in turn.